Very good afternoon, everyone. Very good afternoon, and welcome to your Unit 1 class. Okay, I hope everyone is keeping fine, doing good. Guys, girls, all of y'all, we are in topic number 2, and today we'll be starting part 3. There is one more part after this. Part 4 is also there. However, part 3 will take some time to complete. It's not a short part, it's quite a long part. Okay, right. Everybody, guys, girls, shall we get our writing books out? Everybody? Boys, girls, everyone, can you all get your writing books out, please? And can you all look over here? Students online, can you all also collect part 3? I'm sending it to you all on the chat. So part 3 is over here. Right, everybody, can we come down over here? Everybody, communication protocols. Okay, boys, we have started now. Let's put everything away. Okay, when we come down to protocols, guys, can everyone come down over here? Part 3, page number 4. The starting of this is quite simple. Some basic information that you guys are all most probably familiar with. Okay, right. Can you guys come down to the second paragraph? Can you all see what we're going to talk about? Second paragraph, please. You will now learn about the different ways in which devices can communicate using different network protocols. Everybody okay with this? In the very next sentence, boys, in the very next sentence, I have told you all the meaning of protocols. What are protocols? Protocols are basically a set of rules. Okay, a set of rules that define how data is going to be transmitted. Okay, and your computers, guys, boys, over here, your computers automatically follow all these rules. You don't get a choice, you don't get to choose. The moment you connect to a network, automatically your laptop, your web browser will start following these rules, which we call protocols. Okay, it's a collection of rules. Right, can you guys come down to the next paragraph? Everybody, can you all come down to the next paragraph? By the way, guys, just recalling in the first paragraph, what have I told you all? We have learned about the components of a network. We have learned about the metrics of a network, isn't it? We have learned about network, what infrastructure. We spoke about peer-to-peer, client-to-server, tethering, ad hoc, isn't it? We spoke about the different network models as well. Okay, now we move on to something even deeper. How is data transferred? What are the rules that are followed when data is being transmitted? Everybody okay with it? So far, we know data transfers in the form of, when data is transferred, it is broken into what? It is broken into packets, no? So later on in this chapter, we are going to talk about in detail, how does a packet move from one device and go to another device? How does all that happen? We're going to talk about it in detail. And that's not the end of this topic 2. There is one more part after this. Topic 2, part 4 is also there. Okay, right. Can you guys come down over here? There are a wide range of protocols, rules, set of rules that you need to understand. Most of these protocols are regulated. Okay, there is an organization that's controlling it. Okay, can you guys keep reading it? Called what? Institute of Electrical and Electronics Engineers. Okay, right. Can you guys go through the list of protocols we're going to talk about? Many of these words you guys would have already heard of. Am I right? Okay, Ethernet we have heard of, Wi-Fi we have heard of, Bluetooth we have heard of, Zigbee. I don't think any of y'all have heard of Zigbee, right? Zigbee is something that is not known to you all. Okay, cellular we have heard, infrared we not only heard about it, we spoke about it in detail as well, isn't it? We spoke about in detail. We spoke about infrared waves. Okay, right. Let's start off with Ethernet. Okay, everybody, can you all read it? When we say Ethernet, I'm referring to what? I'm referring to a wired network connection. Agree with me on that? Ethernet means a wired network connection. Now, can you guys read it to yourselves? Okay, so Ethernet is all about wired. So under wired, what are your options, guys? Under wired, what are your cables? You have twisted pair cables, you have coaxial cables, and the fastest of them all is your fiber optic cables. You have fiber optic cables as well. Okay, right. Keep reading it, everybody. Ethernet is still widely used. Okay, because number one, purchasing cost is not very expensive. These cables do not cost a lot. Okay, they are more secure because you have a dedicated connection from the sender to the receiver. Is it clear? When you use a wired connection, it's a dedicated connection from your router to your device. Hence, it's more secure. Read the next one, third. It's reliable. The connection is less prone to electromagnetic interference. It's not affected by distance. It's not affected by physical blockages. Okay, you shouldn't say it's not. It's hardly, isn't it? It does get affected by distance, but not as bad as wireless. Everybody okay with that? My wording was wrong. You shouldn't say it does not. It hardly gets affected. Okay, or it's less affected. Then guys, compatible. Do you all agree with that point? It's a textbook point I have taken. Would you all fully agree with it? Compatible with many devices. In context of today's world, many devices are supporting what? Wireless connectivity, right? So point number 4 is not properly true because in today's devices, okay, desktop computers, routers, yes, it supports an Ethernet connection. But if you look at devices like smartphone, tablets and all, they only support a wireless connection. And read the last point, easy to install. You simply need to connect the cables to your sender and receiver. That's all. Okay. This is Ethernet. How Ethernet operates, it has a set of rules. Those rules, do you all need to know? You all don't need to know those rules. Everybody okay with it? What are the protocols of Ethernet? You all don't need to know. You all just need to know Ethernet is one of our network protocols. Are we good? One of our network protocols is Ethernet. Okay. One of the set of rules that connects devices is Ethernet. Let's move on to the next one. Can we all come down to Wi-Fi? This is a protocol all of you all are familiar with. You all have used it on a daily basis. Go through it. Is a protocol, a set of rules that is used to transmit data wirelessly between two devices. Wi-Fi has two frequencies. What are the two frequencies? 2.4 gigahertz and 5 gigahertz. Look at me, everyone. I told you all when I showed you all the electromagnetic spectrum, I told you all when the frequency increases, what goes down? When the frequency increases, when it can carry more instructions per second, something goes down. Its wavelength. No. When its frequency increases, yes, wavelength goes down. Everybody okay with it? So everyone now read the next paragraph. When the frequency goes up, the wavelength goes down. Okay, the size of the waves becomes smaller. Currently, many of our routers and many of our devices support 2.4 gigahertz. However, this frequency, since many devices support it, the amount of traffic using 2.4 gigahertz is quite high. Are we all okay with this? Nowadays, we have routers that will offer you two connections. You guys, if you all check the routers that Dialog is giving you all, SLT is giving you all, it has two frequencies, 2.4 and 5 gigahertz. Are we okay with this? Okay, I think right now Platinum is also using it. I mean, it's available here. When I come over here, no, if I go to the 4th floor, it's there. On the 4th floor, we are using all fiber optic connections. So for each fiber optic connection, we have broken it into two. You have a 2.4 gigahertz connection. You also have a 5G connection, 5 gigahertz connection. Everybody okay with it? All devices will be able to connect to the 2.4 gigahertz connection. But there are only certain devices that can connect to the 5 gigahertz connection. Which one is faster? Obviously. Which one do you think offers a better frequency? 5 gigahertz. So its bandwidth is much faster. But what do you think about its distance? Its distance, its range is lower. 5 gigahertz has a higher bandwidth, but its range is lower than 2.4 gigahertz. Everybody okay with this? Shall I show this to you all? My laptop supports both. Look at this. My laptop supports both. So when I come to mobile hotspot here, I can see, where is it? Edit. I can choose the bandwidth I want to offer. Is it clear? So if I see many of you are having all laptops over here, I would say, you know what, go with 2.4 gigahertz. But if I see many of you are using tabs and smartphones, I would enable 5 gigahertz. But if I have students at the end of the class, then I might have a problem. So I will say whatever is available, offer it. Everybody okay with this? Right. Can you guys keep reading it? Nothing much to say there. Keep reading it. The 5 gigahertz was developed partly for this reason, so that the traffic accessing the network can reduce, but also because it allows faster transfer of data. Can you guys go through it? So Wi-Fi started in 1997, and initially it was only 2.4 gigahertz, going up to 2 megabits per second. Everybody okay with this? But it is now a lot faster. Okay, so much more faster. The 5 gigahertz was developed in 2009, and speeds went up to 20 gigabits per second. By 2023, we have 6 versions of Wi-Fi protocols. Okay, meaning Wi-Fi can now transfer data up to 10 gigabits per second. The 2.4 gigahertz frequency can go up to 45 meters, while the 5 gigahertz can go only up to 15 meters. Everybody okay with this? This is to do with Wi-Fi. Can you guys move down to the next protocol? Okay, now we have seen 2 network protocols, boys over there. Adil, all of y'all. Can you all come to the third protocol? Bluetooth. This is a protocol which is again being used in today's world. Okay, right. Can you guys go through it? Transmits data wirelessly. What frequency is it running on? 2.4 gigahertz. In Bluetooth, guys, you don't connect devices. What's the word we use? In Bluetooth, you pair devices to each other. Are we good? All right. Can you guys go through the 4th paragraph? So when you switch on Bluetooth, you scan for devices that you can connect to or you can pair with. A list of compatible devices will be shown on the phone, and the user can select the one that they want to pair with. The Bluetooth connection can then be created between the phone and your wireless headset. Sometimes they might ask you for a code. And in most cases, guys, the code is 12340000. Isn't it? We have a very, very simple code. Okay. So in terms of security, Bluetooth is not the best. It has a code, but generally the code is something anyone can figure out. And does it always ask for a code? No, right? If you go on to pairing mode, if any device requests for a connection, it will connect with it. Is it clear? So in terms of security, it's not the best. Okay. Can you guys see the distance? Only a 10-meter range it has. Are you all okay with this? Advantage of Bluetooth. Now, for example, when it comes to Wi-Fi, devices have to be connected to the same router. Agree? So you can move around, but you need to be in range of the router. What if you're traveling? You will not always be in range of the router, no? So when you're traveling and you don't have a router to connect your devices, you can use Bluetooth. It makes sense. At home, your router is there, so your headset and smartphone can be connected to each other. But when you go out, router is not there, right? So then you need Bluetooth. Okay? So Bluetooth is ideal for boys. Bluetooth is ideal for a personal area network. You know what personal area network means? You have devices of your own that you want to communicate with each other. You want your laptop and Bluetooth speaker to talk to each other. Then Bluetooth is excellent. But you want your laptop to connect to your smartphone, then you're going to go for a wide area network. So for a personal area network, Bluetooth is ideal. Okay, and look at the speed of Bluetooth, it's 3 megabits per second. So for accessing the internet, Bluetooth is not good. But for transferring what you call music from your smartphone to your Bluetooth speaker, it's good enough. For transferring health data from your smartwatch to your smartphone, it's good enough. Okay, right. So we have seen 3 protocols so far. We saw Ethernet, we saw Wi-Fi, we saw Bluetooth. Can you guys keep moving? We have another one called Zigbee. Okay, and this is something that you guys are not that familiar with. Can you guys read it? It is also wireless. Everybody okay with this? Right. Which frequency is Zigbee running on? Zigbee is running on 2.4 gigahertz frequency. Keep reading it, guys. I have something to show you all here. Okay. Keep reading it. Zigbee is very similar to Bluetooth, but is normally used to connect different types of devices. Okay, different types. I'll tell you what these types are. Okay, right, keep reading it. Now Bluetooth is normally used to connect a smartphone, a wireless headphone, okay, or your car stereo system to your smartphone. Zigbee is normally used to connect smart devices like thermostat, bulbs, fans, locks, blinds. You get it? Thermometers. I said thermostats. Okay. Can you guys, do you all remember what the Internet of Things are? What is the Internet of Things? Ordinary gadgets, okay, that are connected to each other that create a what for you? That create a smart home for you, right? Normally bulbs and fans and locks and all, we don't connect to the internet now, isn't it? The moment you start connecting these gadgets to the internet, what do we call it? Internet of Things. Ordinary gadgets, the devices that used to be ordinary, not connected to the internet, when you start connecting to the internet, you have all these gadgets communicating with each other now. This is what we call Internet of Things. Okay, so boys, girls, everyone, can you all look at this? Can you all read this example? I couldn't find a proper video for you all. So guys, can you all read this? Okay, components of a Zigbee network. Number one, we have a Zigbee coordinator. Okay, I'll give you all an example. Okay, now this is the main control of the Zigbee network. The coordinator is the main control. It's like the brains of the network. It gets all the devices to work together with each other. Is it clear? Motion sensor detects there was motion in the room. It tells the coordinator. Coordinator tells the bulb, switch on. You get it? Motion sensor detects nobody's in the room. It tells the coordinator. Coordinator tells the bulb, switch off. Everybody okay with this? So the coordinator manages all these devices. Can you all read it now? It's the main control of the network. It creates and manages the network. Okay, so that in every Zigbee network, boys, there's only one coordinator. Look at the example I have given you. An example of a coordinator can be the Amazon Echo Plus. Have you heard about this smart speaker? The Amazon Echo speaker, I love it. It's a smart speaker. You can talk to it and tell it to perform various actions for you. Switch on the bulb, switch off the bulb, switch on the AC, turn on the lock. You know, you can tell it to do various things for you. It's an example of a coordinator, something that manages the whole network. Then guys, inside the network, you will have multiple routers to transmit data to the correct devices. Anyone remembers the function of a router? What was the function of the router? Forwards. Forwards. It doesn't forward IP. It stores the IP address. It forwards what? Data packets to the correct device because it has all the IP addresses, right? What does a router do? A router forwards data packets to various devices. Now, guys, remember, your house is not, it's not one bedroom house now. When you talk about a house, you're talking about many rooms, multiple floors. So you need gadgets from various floors and various rooms to talk to each other. How do you connect all these devices together? Using a router. Not a router, using routers. Using a collection of routers, you will connect all these devices in the house. But read it, guys, in Zigbee, we have something special. Read it. Extends the network range, forwards data packets between devices. It can also somewhat control devices. Read the examples of routers in a Zigbee network. Sometimes a smart bulb can act as a router. A smart bulb will receive data and then decide where to send it. Okay? So it doesn't only act as a light, it also acts as a router, forwarding data to the correct device. Okay? Right. Then guys, the third components that we have are Zigbee end devices. Can you guys read that now? Simple battery powered devices that only talk. Okay, only talk means they only collect input. They don't perform any output. Okay, can you guys read it? Okay, they do not route traffic. They only receive input. Mostly it is sensors. Okay, in most cases, your Zigbee end devices will be the thermostat, sensor, motion sensor, light sensor. Okay, sensors. They use very little power and often sleep to save energy. Can you guys see the examples? In most cases, your Zigbee end devices are sensors. Everybody okay with this? Can you all see the example I'm giving you? Can everyone read this example? Adil, I think I need to change your place. You don't seem to be working today. Can everyone go through the example over there? So you have an Echo Plus, Amazon Echo Plus smart speaker with you. This is your coordinator, the brain of your Zigbee network. Read the next one. You have a Philips bulb. This is a bulb and it is also a built-in router. Okay, keep reading it. You have a motion sensor in the room. A motion sensor can detect movement. Keep reading it. If you walk into the room, the motion sensor is an input device now. It will detect somebody has walked into the room. It sends a signal. It only talks. It sends a signal through the bulb. Okay? Everybody, do you all understand this? The motion sensor will detect your movement and it will tell the bulb. The bulb is also a router now. So what will the bulb do? What will the bulb do? The bulb is also a router. It will also forward that data packet to the coordinator. Now the coordinator will make a decision. Somebody is present in the room now. So the coordinator will then send a response to the bulb saying, switch on the light. Okay, can you guys read it? So here the coordinator is the echo speaker now. The echo plus will then tell this light, okay, switch on. Everybody okay? Then let's say the person walks out of the room below. So sensor will detect no movement, no movement, no movement. What will it do? It will keep sending it to the bulb. The bulb is also a router. What will the router do? It will send that data to the coordinator. The coordinator will have a rule. After 5 times of nobody being in the room, it will then prompt. It will then send a reply saying, turn off the light. So how does that go? The reply goes to the bulb and the bulb will then turn off the light. Are we all okay with this? Many of you all do not know Zigbee because many of us, for our smart devices, what do we use? You guys must be having some smart bulbs at home, right? At least smart doorbells, door cameras. We don't use Zigbee. We are all using. Okay. If I were to fix a smart bulb over here and if I were to control it from my smartphone, how would you tell me to control it? How would you tell me to connect it? Through Wi-Fi, isn't it? We are all used to Wi-Fi. Is it clear? And many products support Wi-Fi. Not many products, almost all products support Wi-Fi. But do all products support Zigbee? Answer is no. Everybody okay with this? And when it comes to a Wi-Fi network, do you need a coordinator? You don't need a coordinator, right? Isn't it? Okay. So everybody, Zigbee exists. It has its own way of working, but it's not very popular. Maybe in certain parts of the world it might be popular, but over here it's not that popular. Okay, we simply use Wi-Fi to control our gadgets. Everybody okay with this? Okay, right. Can you guys come back over here? Can you all read the example I have given you all? To create a Zigbee network in a building, a Zigbee hub. Guys, we'll stop there. Instead of hub, you can say router. Everyone, can you all also put that word on top? Instead of hub, you can also call it a router. Now guys, your router is also a what? Boys, girls, your router in a Zigbee network can also be? No, coordinator is separate. Yeah. Your devices can also be, your router can also be a device, right? Your router can also be a smart device like a smart bulb, a smart lock, isn't it? A smart fan, a smart AC, a smart TV, a smart thermostat. Okay? No, I made a mistake here. Everybody, not hub. For hub, we will call the hub the coordinator. Can you guys put that over here? A Zigbee hub is needed. So for hub, can you put the word coordinator, not router? Okay? For hub, can you guys put the coordinator? My bad. Okay? For hub, you guys will put coordinator. Can you guys see the data transfer speed? 250 watt. 250 kilobits per second. Look at its range. It has a range of 100 meters. Everybody okay with it? It has a transfer speed of 250 kilobits per second. It has a range of 100 meters. Okay, so its range is less than that of Wi-Fi. Okay, Zigbee has a smaller range than Wi-Fi. Are we good? Right. Shall we move on to the next one? So we have seen Ethernet protocol. We have seen Wi-Fi. We have seen Bluetooth. We have seen Zigbee, which many of us are not that familiar with. We now move on to the next one, which is cellular, your SIM card connectivity here. So under cellular, we have 3G, which we are not using anymore. Instead, all of us are using 4G. Some of us might have subscribed to 5G. Are we good? Most of us are using 4G. Some of us might have subscribed to 5G. Can everyone come down to cellular network, everybody? Guys, girls, everybody. A cellular network is what mobile phone users, SIM card users connect to when they want to carry out actions on their phone, such as make a phone call, such as access the internet. So everybody, can you guys look over here? Everyone look over here. Can you all see? I took this image from your textbook. Okay, can you guys look here? Can you all see this honeycomb kind of structure? Now, when you are speaking on your phone, guys, your signals will go to the closest signal tower. Everyone saw this? Your signals will go, everybody looks here. Can you all read this? Local base station, the signal tower that is closest to your smartphone, transmits to receive. No, who is that? We need to go the other way. The other way. We start from the left side. We start from the left. The person on the left is talking to the person on the right. Okay, mobile phone talks to local base station. Whatever this person on the left speaks, his signals go to the closest signal tower. Everybody okay with that? Then from that signal tower, it goes to the next signal tower. Is it clear? From this signal tower to this signal tower. At this signal tower, it gets strengthened, amplifies. And then what does it do? It comes to a what? Central base station, transmits signals to receiving local base stations in other cells. Everybody okay with this? So from signal tower to signal tower to signal tower to signal tower, finally reaches the user's phone. Everybody okay with this? This is how a cellular network works. How does it work? Signals go from signal tower to signal tower to signal tower until it reaches its destination. Are we good? Okay. So what do signal towers do? What are these signal towers in between doing? Everybody, why are signals going from signal tower to signal tower to signal tower? To get amplified, to get strengthened, isn't it? You know, as signals travel a long distance, their quality starts to weaken, isn't it? Their signal quality starts to weaken. So you need base stations on the way to collect it, amplify it, strengthen it, and then send it to the next signal tower. Everybody okay with this? Do you all now know why is it that when you get into a lift, signal drops? When you get into a lift, when you go inside a tunnel, when you go to mountainous area, signals immediately drop. Because of what? Sorry? Okay, radio waves. Very nice. So radio waves are used to transmit data from your smartphone to a signal tower. Okay. So inside a lift, you're surrounded by what? Massive amounts of extremely thick metal. So signals find very difficult to go through it. Is it clear? So signal towers are unable to reach, the signals are unable to go and reach a signal tower because it's being blocked by thick metal. When you go outstation, guys, certain areas, signal towers are not available. Is it clear? So for example, close by, there is no signal tower. The closest signal tower might be somewhere over here. So by the time signals from here reach here, the quality is already poor. You don't have a signal tower close by to your hotel. So what happens? Signals have to go to the next closest signal tower, which is quite far away. By the time signals reach this tower, the quality is already poor. Is it clear? So the person who is hearing you, what would he say? I can't hear you properly. There's a lot of background noise, a lot of disturbances. Your voice is echoing. It's breaking up. You guys would have had this, right? Sometimes you talk to somebody outstation and they say, you know what, I can't hear you properly. It's always breaking up. That's because there is no signal tower close to you. Are we all okay with this? Everybody? Okay, this is what we call cellular networks. Okay? Guys, girls, all okay with this? Okay, so we have seen various network protocols. Okay, various ways in how networks operate. Okay, we saw Ethernet, the wired connectivity. We saw Wi-Fi, we saw Bluetooth, we saw Zigbee, and now we have come down to cellular. Then guys, girls, our last one, where we, can you guys quickly read this? Read this description and see whether it matches with what I told you. When a user calls their friend using a phone, the data is transmitted from the phone to the closest base station. Okay? If their friend is also within that same honeycomb cell, everybody, if your friend is also here, let's say I'm talking to somebody in the front office right now. Both of us would be in the same cell, right? Both of us would be in the same honeycomb cell. So then the same signal tower will be used to transmit our signals. Everybody okay with this? If you are both physically in the same honeycomb cell, then the same signal tower will be used. But what if we are not in the same cells? What if we are, physically far apart from each other? Then what do? Can you guys keep reading it? If the friend is within the same cell, then the data is transmitted from the same base station to the friend's phone. However, if the friend is within a different cell located physically far away from me, the data is sent from base station to base station until it reaches the base station in the cell where the friend is. Nothing complex there, no? Okay, station to station, but it happens so fast. Happens very fast. And then from the base station to the friend's phone. Okay. So for mobile phone calls and mobile phone SMS, we use a system called what? GSM. Everybody okay with this? Can you guys go through it? We have something called GSM. These are the rules that govern how the data is sent. These protocols can be known as the term 2G, 3G, which we are not using anymore. Instead, we are using 4G and 5G in today's world. Can you guys see the different speeds? 2G supports only 0.1 Mbps, 3G is 42 Mbps. So right now I am showing you all the bandwidth, the maximum that can be supported. But the speed will be a lot lesser. Reality will be a lot lesser because there'll be various factors, interference, traffic, things like that. Okay. Right. Everybody okay with this? Right. You guys, everybody, we just spoke about protocols now. The protocols that we just spoke about, we are going to call them communication protocols. Okay, to make it a bit easier for you all to understand. Ethernet, Wi-Fi, what else? Ethernet, Wi-Fi, go on. Bluetooth, Zigbee, cellular. Wi-Fi, nobody said no? All said Wi-Fi. Okay, there is one more which we spoke about in our previous class, which I haven't mentioned here. There is one more connection medium you can use, but you guys rarely use it, but you all might use it for, if I tell it, you all immediately know the answer. There is one more communication medium, not very secure, distance is very small. What do you say? Infrared. Everyone know about infrared, right? Infrared, receiver and sender have to be directly in what? Not contact. Line of sight, projector and this remote. If I turn the remote this way, it will not talk to the projector. Projector and remote have to be directly facing each other. How about the distance? Distance is also the range is very small. How about the bandwidth? Bandwidth is also very small. You can carry very small messages like switch on, switch off, play, pause, small messages only it can carry here. Everybody okay with it? So remember, we have one more which is infrared, which we learned in our previous part. Everybody okay with this? We have one more over here, which is infrared. These are all communication protocols. Okay, we now come down to something called network protocols. This is where things get really complex. Okay, all right. Can you guys come down over here? Please take your writing books also. Girls, boys, everybody online, bear with me. There is a further set of protocols, set of rules that are used to govern. It's too cold there. Can you come and take the remote? That are used to govern the transmission of data across a network. Okay, everybody, can you all read the 4 types we're going to talk about? We are going to talk about something called open systems interconnection model. This will be the most confusing model you guys will ever come across. Then we have something called TCP IP, we have something called VoIP, and we have something called SIP. Everybody okay with this? Boys, girls, everyone with me? Right, guys, girls, everybody. Can you all get your writing books, guys? Can you guys tell me how does data travel in a network? I asked it to you all earlier on. So you all told me in the form of data packets. Guys, I gave you all a diagram of a data packet. Anyone remembers a diagram? Every data packet had 3 main components. What were those 3 main components? Header, payload, and your trailer. Can we write that again just to remind ourselves? Everybody? Structure of a data packet. structure. Boys, can we sort that out now? Everybody okay with this? Structure of a data packet, and we so far only know three parts, which is your header, your payload, and your trailer. So we have three parts. Every data packet contains this. What are those three parts? Your header, your payload, and finally you have your trailer. Everybody okay with this? Now guys, boys, all of y'all, to explain how these data packets travel from a sender to a receiver, we are going to talk about an entire journey. Everyone okay with this? How does data travel from one computer to another computer? Are we all okay with this? Okay. Boys, everyone, come on. What's wrong over there? Sort it and put it away, will you? Sorted? Okay, now come and keep the remote over here, will you? Come and keep it over here, will you? Okay, so everybody can you put down the heading, the OSI model. What does OSI stand for? Open systems, open systems. What do we have? Interconnection. This is what we call the OSI model. So everybody, this OSI model, it has 7 layers. Okay, everybody, there are 7 layers over here. Each layer explains what happens to your data packets. Are you okay with this? There are 7 layers over here. Right at the top, everybody, right at the top, we have layer number 1, where we have what we call our application layer. Everybody, okay with this? We have our application layer over here. Okay, so basically application layer is the layer that is responsible for telling what type of data you're using. Is it clear? Is it website data? Is it email data? Or is it a file that you're uploading or downloading? Okay, can you guys come back to your tute, everybody? Can you all read your tute? What does it say about your application layer? Can everyone have a look over here? You all need to go from the bottom now. I have started the other way around. Can you all go down to page number? Can everyone come down to page number 9? Provides network services directly to user applications. Okay, right, everybody. No, I'm confusing you all. Everyone, let's go the other way around. We'll go from physical layer and then I'll keep going upwards. Okay, I'll start with physical layer, but Where is my this thing? Yes, everybody. No, let's remain like this. Everyone, can you all read the application layer? Provides network services directly to user applications. Everybody, boys, when you're transmitting data, it might be website data. So then you're using a web browser. Everybody okay with this? Or it might be accessing email services. Okay, then you will use rules that define how the email is going to be loaded. Or for example, you might be uploading and downloading files. Then you'll be using protocols that define how you have to upload and download your files. Okay, can you guys read the function? This is the topmost layer where user applications and network services interact. Sounds confusing? Just give me some time. I'll break it down for you all. It includes protocol, like for example, if you're using email, it will use a protocol called what? SMTP. If you're uploading, downloading files, it uses a protocol called FTP. If you're web browsing, it uses a protocol called HTTP. If you're web browsing a site where you will be submitting sensitive data, you will be using HTTPS. Everybody okay with this? So can we just mention the protocols that we use over here? Can we just mention the protocols that we use over here? Okay, so over here we will be using HTTPS. We will be using, if it's email, SMTP. Everyone okay with this? Then for example, if you are using, what do you call? If you are uploading, downloading files, it will be FTP. These protocols are used. Then the second layer, everybody, then we move down to our second layer, which is our presentation layer. I'll tell you all what happens over here. Okay, your presentation layer. Now in application layer, your data has been formed now. Whatever data you're going to send, it defines the application that is going to receive it. Is it going to be a web browser? Is it going to be an email client? Is it going to be uploading, downloading files? That has been defined. Now it's time to send it. In presentation layer, three things happen. One is translation. Second is compression. And the third is encryption. Three things happen in your presentation layer. Just before you send it, just before you send the data, three things happen. What are the three things? Translation. The second thing that happens is compression. We all know what compression is, right? Okay. Making your file size smaller so it can transfer quickly. Compression. And the third thing is encryption. Securing your data. Encryption. Okay, everybody? So in layer number one, in our application layer, we define the application that is going to be used and the application that will be used to receive this data. Those rules have been established. Then guys, in the second layer, we did our translation, our compression and encryption of all the data packets. Now in the third layer, we call this the session layer. Can everyone come over here? Session layer. Over here, what happens? Something called SIP is used over here, which we will learn in detail later on. Session Initiation Protocol. I'll put the full form over here. Session Initiation Protocol. Are we all okay with this? Basically, guys, over here, what happens? The sender is setting up a connection with the receiver. Everybody okay here? Over here, what happens? The sender and receiver have now established a connection. Everyone okay with this? Okay. Establishing a connection between sender and receiver. A connection between sender and receiver. Then guys, everybody, next what do we have? We have our transport layer. Now guys, connection has been established. You and the receiver now have a connection. Now you all have to decide how are we going to send this data. Are we going to use express delivery method or are we going to use normal delivery method? I'm just using real life examples. There are two protocols that are used over here. Something called UDP and something called TCP. The differences between the two will come to you all later. Everybody okay with this? Everyone over here, you can use UDP or you can use something called TCP. Okay, so basically what happens over here, the delivery method, how are we going to deliver these data packets? How are these data packets going to be transported is defined over here. Everyone okay here? In transport layer. Okay, so I'll just put a note over here. Delivery method is defined over here. Then guys, girls, UDP stands for User Datagram Protocol and TCP stands for Transmission Control Protocol. Can we just put a quick note over there? Okay. Below transport layer, I'm just going to put a quick note over there about what is UDP and TCP. User Datagram Protocol. It is extremely quick but not reliable. Okay, quick delivery of data packets, quick delivery of data packets but not reliable. But not reliable. Typically we use UDP for I need the data immediately. We normally use it for live streaming. Everyone okay with this? When you go for live streaming, guys, in that connection, normally UDP is used. Everyone okay with this? User datagram protocol is used. That's why, guys, in live streaming, is it possible that sometimes you might miss a certain part? 2-3 seconds, you might miss it, might jump to the 10th second. Is it possible? That happens, right? Sometimes you lose your data, you never get it. Everybody okay with this? That's because UDP is used. UDP is quick but not reliable. Okay, you can lose data packets on the way. Okay, and data packets that are lost are not resent also to you. You get it? Okay, quick delivery of data packets but not reliable. Example, live streaming. Example, live streaming. Are we okay with this? We have another one called TCP, Transmission Control Protocol. Extremely reliable but not the fastest. So normally when you load a website, when you load websites, guys, you're normally using TCP. It's not very fast, but it's very reliable. All your data packets, even if they get lost on the way, they are resent to you. The website will fully load for you. Everybody okay with this? So can you all note that down? What is TCP? Transmission Control Protocol. What did we say here? Not very quick, but very reliable. Okay, example, loading a web page. Example, accessing a website. Example, loading a web page. We have one more, guys. I forgot to mention it earlier. We have one more, UDP, TCP, VoIP. We have one more. VoIP is used only for one purpose. Anyone knows, even though I didn't teach it yet? Voice over Internet Protocol. We only use it for calls. Only for internet-based calls it is used. Okay, I just need to know that. Okay. VoIP. voice over internet protocol. Again, quick and not reliable. Not very reliable, you can say. Quick delivery, but not very reliable. Shall I ask you all why? Not very reliable, used only for calls over the internet. Okay, video conferencing and the normal phone call, audio call, we use VoIP. Used only for internet calls. I hope you all can read my handwriting. Okay, everyone okay with this? VoIP is used only for calls over the internet. And guys, in VoIP, guys, all of you all, in TCP, if a data packet gets lost, that data packet will somehow or the other be brought and given to you. You get it? While you are loading a web page, let's say data packet 3550 got lost. What will TCP do? TCP will tell the sender, send it again, and you will get packet 3550. In VoIP, that doesn't happen. Everybody okay with it? In VoIP, if a data packet is lost, it's lost. It's never coming again. Is that a good thing for you? Why no? Practically think and see, if you're on a phone call, a data packet didn't come to you on time. It's coming to you 10 seconds later. Imagine how your call experience will be. It will be a mess, right? Isn't it? Especially for phone calls, if data packet gets delayed, better it never come to you than come to you later. Is it clear? It will mess up the whole flow of the call, isn't it? So everybody remember, for internet calls, we use VoIP, where it's quick, but it's not reliable, and it's good that it's not reliable. Because we do not want data packets coming later on, it will mess up the call. Are we all okay with this? Okay. I want to tell you one more thing, I forgot about it, about VoIP. Anyway, guys, so everybody, can we imagine, like you're sending a friend a parcel? So initially what you do, you first, prepare you first prepare your parcel that's going to be sent to your friend. Is it clear? So first you might use, I don't know, you first have the item that you're going to send now. It might be a paper document, or it might be, I don't know, a box item, or it might be food, whatever. That's your application layer. You're putting the item together. Presentation layer is where you do the packing. So it can go for sending. Your third layer, session layer, is where you tell your friend, okay, you know what, a parcel is coming for you. Are you ready to receive it? This is your session layer. Now your transport layer is where you choose your postman, you choose your delivery method. Should I go for express delivery, normal delivery? This is where you choose your delivery method. Okay, your parcel is now ready for sending. Your friend has told you, you know what, I'm ready to receive it. Is it clear? Now you start, what do you call it? Now you choose your delivery method. Do we go for express or normal? Okay. Then guys, what do you think the next step will be? Your next step will be collection. Before collection, delivery. Before delivery. So everybody, our next layer is, everyone. Yes, our next layer is going to be our network layer. Everybody, our next layer is going to be our network layer. So everybody think and see, if I'm not mistaken, on Uber Flash, or Pick Me Flash? Uber what? Pick Me Flash. Uber calls it what? Whatever. On Pick Me Flash, sorry, Connect, Uber Connect. Okay. Everybody, your next thing is to tell where to deliver this. Agree? Isn't it? Your next thing is to tell where. In a network, what protocol do we use to identify a network? In a network, what protocol is used to identify a device in a network? Sorry? IP addressing, isn't it? So over here in network layer, we want to know the address of the network. We want to know the address of the network. So over here we use IP addressing. Now you mention the address of where to deliver it to. Okay, so over here what do we mention? IP addressing. IP addressing is used here. Here you mention the IP address. Everybody okay? You all know IP address is a long address, right? The IP address is an address that will tell you where the network is, how to get to the network. So in network layer, you mention the IP address. Then guys, once you get to the network, you have to identify a device, right? Devices are uniquely identified by IP address, also by MAC address. Everybody okay with this? So in layer number 6, we talk about what? We talk about data link layer. Data link layer. Data link layer. Over here, what are we interested in? We are interested in MAC addressing. Over here, we are interested in MAC addressing. Keep some space. I have another note for you all. And then finally, guys, we have something called the physical layer. Physical layer. So what does physical layer do? Physical layer deals with your actual data, whether it is going to be received in a wireless method or whether it's going to be received in a wired method or wireless method. Everybody okay with this? In your physical layer, you will now deal with wired or wireless. How is the data going to be received? Wired or wireless? Everybody okay with this? Before I explain this, guys, can you all tell me which component of a network deals with IP addresses? Which component of a network deals with IP addresses? The router. Agree with him on that? The router deals with IP addressing. So over here, I'm just going to put router. Here you work with the router. Which network of a component, which component of a network deals with MAC addresses? No. NIC has the MAC address, but for a network, who stores the MAC addresses? The switch. Agree with him? I told you guys right some time ago, what does the switch have inside its memory? Inside a switch, in its memory, it has a table called MAC addressing table, where the port number and the MAC address is stored. Is it clear? So over here, we work with switches. Over here, we work with switches. Everybody okay with this? Shall we go from top to bottom again? Let's go from top to bottom again. So everybody, let's take the example of you sending a parcel to your friend. You're sending a packet to your friend. So application layer will deal with what is the contents of the parcel. Application deals with whether it's food, whether it's a printed document, whether it's a hazardous chemical, for example. Okay, the content of your packet will be dealt with in application layer. Then in over here, then in presentation layer, we talk about the packing of your packets. Okay, how do you pack it? So in computer terms, we talk about translating that data into a language the computer understands, compressing it so its file size will reduce, encrypting it so that nobody in the middle will be able to understand it. Everyone know what encryption is? Encryption is what? Scrambling your data into an unreadable format. Encryption is where you scramble your data into an unreadable format. Right. This is 2. Number 3, what happens? You now inform your friend, you know what? I'm sending a parcel. Are you ready to receive it? In computer terms, what do we call that? Session initiation protocol. Basically, what does session initiation do? It tells the receiver, it establishes a connection with the receiver. Then only the next layer will take place. What is the next layer? Transport layer, where now the delivery method is chosen. So if it's a live streaming video, you will go with what? UDP. But if it's, let's say, for example, a server talking to a client where the client is requesting for a website, it will most probably use TCP. But let's say it's a WhatsApp call, you will be using VoIP. This is your transport layer. Everybody okay with this? Then we come down to network layer. Network layer is your identifying your network. Is it clear? Trying to find the network. This is network layer. So we talk about IP addressing here. Once we know what network the data packet needs to go to, now we need to talk about which We now know which network to go to. Now what are we interested in? We now know which network to go to. Your parcel knows which apartment to go to, which building complex to go to. Your next thing will be the device. Which device do we give this to? Is it clear? The next thing is the device. So here we talk about data link layer. How do we identify the device? By its MAC address. And then finally, what do we have? Finally, we have how do we give it? Okay. Is it going to be wired method or wireless method? Everybody okay with this? Over here, we talk about the physical layer. Are we going to give it wired or wirelessly? Over here, we have your actual bits of data. Your actual bits of data will be wired or wireless. Everybody okay with this? Sounds okay. Right. Then guys, girls, you all took this fully down? Took this fully down? Right. Can you all read the tute now and see if these two match with each other? See if these two match with, because I'm going to make it a little more complex for you all now. Can everyone read this and see if the two match? Can you all start from the bottom, application layer, and then keep building up on it? So presentation layer focuses on data translation, encryption, and compression. Then you have your session layer. Okay, creates a connection between the sender and receiver, maintains it, and once the transfer is done, terminates the connection. Okay, then everyone, next what do we have? We have our transport layer. Okay, and ensures end-to-end communication, error recovery, flow control. Okay, so here we have TCP, VoIP, or UDP. Then you have your network layer, deals with routing of data packets. Then you have your data link layer, which deals with the MAC address, specific device. So there are some words they are framing. I never taught you all framing. Give me some time. I'll teach you all these words. Okay. And then we have our physical layer, which deals with, is it a wired or wireless connectivity here? Now, guys, girls, I know you all are all confused. And in my experience of teaching this, this is the point where students start to think twice. Should I have selected IT? This is where that doubt comes into your mind. Okay, but guys, remember, the first time you start something is always confusing. If you keep practicing with yourself, okay, these things are going to make sense. Okay, time and again, we'll do some revision on this, but from your side also, as you keep practicing this, as you keep answering past paper questions related to this, after some time, this automatically falls. Okay, it just settles in your mind. The best way to understand is compare this with you posting something to a friend. Not posting, what do you say? Couriering. You say couriering, right? You are sending a package to somebody via Pick Me Flash. Try to compare that process with how data packets are transferred. Then it becomes a little easier for you to understand. Everybody okay with this? Because there is another model as well. Okay, we have a shorter model. But before you guys look at the next model, there is some more information for me to give you all. Can you all just read the explanation over here? The OSI model is a framework that was developed in 1984. Read the next paragraph. What does it say? It is only a theoretical framework. You guys get it? Practically, it doesn't. All this doesn't happen. Practically, all this doesn't happen. It's only a theoretical framework. Only to explain, we use it. Practically, doesn't go through all these layers. Okay, keep reading it, guys. That can be used as the basis for structuring the transmission of data from one computer to another across a network. To explain how data gets transferred from one computer to another computer, we use the OSI model. It's only a theoretical model. Practically, what happens is slightly different, which I will talk about later. Keep reading it. The OSI model divides the protocols into multiple layers. There are 7 layers, each having a specific function. Data is passed from one layer to the next. Many other protocols are based on some of the layers of the OSI model. Now, guys, girls, everybody, you all have your 7 layers, no? In your notes also, you all have it, no? Everybody okay with this? Right. I want you all to take down a small note with me here. Everybody, look at this image over here. Everybody, we have our, what do you call, our physical layer, no? We have our physical layer. Basically, guys, this is what is there in your physical layer. It's just bits of data. Your data packet, what does it contain? It contains only bits of data. Everybody okay with this? Then from physical layer, when you move on to your data link layer, what gets added? Everyone, you have your data. These ones and zeros is here. Can you all see my cursor? Everyone see my... Give me a second. Let me use the pen. Everyone, this is now here. Everyone saw? Can you all see the header area? In the header area, what do we have? We have the MAC header. MAC header means what? Sender's MAC address, receiver's MAC address. Okay? We have the IP addresses. IP addresses is what? Sender's IP address, receiver's IP address. Then we have what do you call delivery method. Are we using TCP? Are we using UDP? Are we using HTTP? Not HTTP, man. VoIP. Then we have one more in the header. What do you call it? The application layers protocols. Are we using FTP, HTTP? What application protocol are we using is also mentioned. Okay. So guys, you have your payload and you have your header. One more thing is supposed to be there, right? Which is your trailer. I'll talk about that in a little while's time. What is there inside your trailer? Coming up after the break. Then guys, can you all see in the next layer what happens? Can you all see what happens in the next layer? Everybody, we went from physical layer, we came to our data link layer. I'm going to erase this. Clear all right. Everyone, from physical layer, I came to data link layer. Okay. In data link layer, what are we interested in? Look at your notes and tell me. In data link layer, what are we interested in? In data link layer, we are interested in the MAC address, right? Now MAC address is solved. MAC address is solved. Now from data link layer, when I come to network layer, is the MAC address still there? MAC address is not there because we solved the MAC address. That's done now. We found the device. Now we're going to talk about the network. In the network layer, what do we have? Sender's IP address, receiver's IP address. Then what do we have? What do we have? Delivery method. What do we have? Application protocols. We have our data trailer. I will talk about later on with you all. Then guys, when we go from network layer to transport layer, what happens? Do we need to have the IP addresses in network layer? In transport layer, we don't. IP address has been solved now. We don't need it anymore. So IP has been taken out. This particular frame has been taken out. Now what do we have? Our transport method. Any application related protocols are over here and our actual data is over here. Is it clear? Now, which layer am I in? Can you see my cursor moving? Which layer am I in? Which layer am I in? I'm in transport layer. I'm in transport layer. Now, from transport, I'm going to move on to not application, about session. Now, my transport problems are solved. Now, I'm in session. So, guys, in session, what happens? In session layer, I don't talk about the transport anymore. Transport method was already solved. Now, we're talking about what? We are talking about no connection. That connection was in transport layer now. HTTP is what? The application layer protocols is there and our actual data trailer I will talk about later with you all. Then guys, finally what will we only have? Now here, what's going to fall here? Is anything going to fall here when I come to the application layer? From the presentation layer to transport layer, from presentation layer to application layer, is anything going to come off? From presentation layer is responsible for what? Translation, encryption, and compression. Is any of that mentioned over here? No. So again, in the application layer, these two will again move to the application layer. Everybody okay with this? These two will again move to the application layer. Are we all okay with this? Okay, this sounds pretty confusing. Okay, but bear with me. As you keep practicing this again and again, it will slowly fall into place. Okay, right, guys, girls, all of y'all, we will be drawing. I have kept big spaces for y'all, right? Did y'all notice? In between your notes, I have kept big gaps. I have kept those big gaps for y'all to draw these frames. Everyone okay with this? If you look at your notes, everyone look here. Can you all see these big gaps over here? These big gaps, I have kept it for you to draw your what? For you to draw these frames, okay, which we will do after the break. All right, can you guys just have a look at the second model? And when you come back after the break, we will go into the details of this. Can everyone come down to the second model? The TCP IP model. So everybody, the TCP IP model is older than the OSI model. It was developed by the US Department in the 1960s. The TCP IP model is a protocol that has 4 layers only. It's basically a summary of OSI. And practically in today's world, we use the TCP IP model. Okay, OSI is just a theoretical model to explain how networks work. Practically what happens in real life is the TCP IP model. Data is transmitted following the TCP IP model. Okay, now guys, y'all can take your break now. We'll be back at 1:30. When you guys come back, I'll be drawing the frame structure for the above 7 layers. Okay, right guys. Right, everybody, can we draw the frames? Everyone look over here. In your physical layer, guys, girls, all of y'all, in your physical layer, what are we dealing with? We are dealing with whether it's wired or wireless, and we are dealing with raw bits of ones and zeros. We are basically dealing only with ones and zeros. Either those ones and zeros are going to go through a wired medium or they're going to go through a wireless medium. Everybody okay with this? So over here, guys, everyone, over here, what am I going to draw? My frame is basically going to be like this. Okay, zeros and ones, which we call raw bits. We basically call it raw bits. This is what we have in our physical layer. Everybody okay with this? It's frozen, sorry. Guys, girls, I'll erase this and draw it again. Over here, boys, everyone, over here. What did this thing say? Everyone look here. You just have ones and zeros over here. Everybody okay with this? You just have ones and zeros over here. I'll just say raw bits. Okay, you just have raw bits over here. Raw bits. Everybody okay with this? This is what you have in your physical layer. Raw bits, zeros and ones, which are either going to go through a wired medium or through a wireless medium. Everyone okay with this? Then in our data link layer, we are going to add lots of things. Okay. Then in your data link layer, guys, those raw bits will become your data. Okay, everyone look here. In your data link layer, you have your data. You have your actual data. Everyone okay with this? You have your data. Then over here, guys, you have another thing which we call your trailer. I'll draw it even bigger because I don't have space. You have your trailer over here. inside your trailer, this is called our trailer area. Inside this, guys, you have two things. You have your sequence number. I'll tell you what this means. Sequence number. And here you have a error checking method. I'll tell you what this also means. Error checking method. Boys, girls, everyone, note this down in your notes below. Everybody. So from physical layer, in physical layer, you had only raw bits of ones and zeros. Okay, boys, let's work now. In your physical layer, everybody, in your physical layer, you had only raw bits of ones and zeros. When you come into your data link layer, lots of things are going to be added. Okay, lots of things are going to be added. You have your raw bits, which we call data. You have a trailer. The trailer contains your sequence number, because guys, there's going to be a lot of packets of data. Everybody okay? So every packet will have a sequence number. You will also have a mathematical formula in the trailer for you to check whether there are any errors in your data. You all don't need to know what that formula is. You all just need to know inside your trailer, you have a sequence number and you have an error checking method. Then what do we have in the header? We have lots and lots of things in the header. Okay. So what do we have in the header? You have your application protocols. Can you understand this? You have your application protocols. You have your transport protocols. You have your transport protocols. Sorry, my bad. You have your transport protocols. Transport protocols. You have your IP addresses, senders IP, receivers IP. I'm running out of space again. You have your IP addresses. Boys, you have your IP addresses. You also have one more, which is your MAC addresses. You have your MAC addresses. When I say IP address, I'm talking about senders and receivers. When I say MAC address, senders MAC address, receivers MAC address. Can you guys work on this? I want to just check one thing, guys, online. Give me a second. I want to quickly check on one thing. Okay. This entire area, everybody, can you all put a note over here? This entire area is your header. Everybody okay with this? This entire area up to your data is your header. Is your header. Okay. What do we call this? We call this a frame. We call this a data frame. We call this a data frame. Okay. This entire thing is called a data frame. This is called raw bits. Okay. Then guys, give me a second, I'll take attendance quickly. 1 second, please. Boys. Okay. So now guys, in data link layer, what do we deal with? Anyone remembers? We focus on MAC address. Now MAC addressing is done. So when you come down to network layer, do you need to put the MAC addresses again? You don't. MAC addresses are going to get removed. Okay. Your MAC address and your trailer are going to be removed once you come down to network layer. Once you come down to network layer, your MAC addresses and your trailer will be removed. Okay. So everyone, what do we have now? Over here, the data, you're going to have your data. Boys, over here you have your data. Okay. Then you have your application protocol. Application protocols. Then you have your transport protocol. You have your transport protocol. You have your, what is remaining? Your IP addresses. You have your IP addresses, senders and receivers. Okay. So our payload is still there. Our payload is still there. And our header partially still there. Header is also still there. Everybody okay with this, guys? You all should be taking this down. Talk to yourselves and take it down. When you go from what do you call data link layer to network layer, the MAC addresses and the trailer are removed. Now you have your IP addresses, transport protocols, and application protocols in the header, and you have your payload. Your payload is basically your data, those bits of ones and zeros. Then, guys, what do you think happens when you come to transport layer? What's going to get removed? Your IP addresses will get removed. Everybody, what do we call this? We call this a packet. We call this a packet. So from raw bits, it became a data frame. From data frame, it became a packet. Okay. Oh, sorry, not packet. IP datagram, they call it. My bad. IP datagram, they call it. IP datagram. Then from network layer to transport layer, you will notice the IP addresses are going to get removed because we know the IP addresses now. No? So now what you have? You only have your data. You have your data. You have your data here. And you have your application protocol. And you also have your transport protocol over here, which is going to be removed very soon. So everybody, boys, this is your payload. This is your payload. And this area over here is your header. What do we call this? We call this a boys, come on. Okay. Then guys, now from transport layer, we now know our transport protocol. So when I go to the next one, what's going to go out? When I go out, when I go to the next one, transport protocol is going to go out. Only application and data will remain. Only application and data will remain when I go into my session initiation, when I go into my session protocol. Everybody, when we go into session protocol, automatically transport will be put out. You will have only application and data. Okay. Boys, everyone with me? Okay, so I'm going to scroll down to the next page. Can I? Okay, so now transport layer, something is going to fall off. The transport protocol will be removed. In session protocol, what do we have? Again, we have our data. We have our data again. We have our data over here. And we have our application protocol over here. Application protocol. Everybody again, this is your payload. And this is your header. This application protocol and data will go up to your application layer. Are we all okay with this? Up to your application layer, it's gonna go on. Okay. Right. I want you all to take a separate note in your writing book. Okay. Okay. Everybody in your writing book, I want you all to take a separate note. We will say computer A is going to send data to computer B. And I want you all to tell me the order we are following. What is the order when I'm sending data? What is the order when I'm going to receive data? You get my question? First finish this fellow. Okay. So everybody in your writing books, can you note down something like this? Computer A is sending data to computer B. So guys, what do you think the order will be for computer A? Computer A is going to send, it's going to, let's say computer A is a server computer. It's going to send the ICMAN website data to computer B. Give me a second, please. So what do you think the order will be? Start with, I'm about to send the data. I'm about to send the data. It's not ready. I'm about to send. So I will start with application layer. Agree? When you are sending, you start with application layer. So everyone, what do? We start with application layer. Where is it? Application layer. Okay. Then what do? You go down to the, so application layer is where you, what do you call? Define, is it website data? Is it uploading, downloading a file? Is it an email? So here you will define, we're going to use HTTP to transmit the data. After application layer, what do you do next? You then compress the data, translate the data, encrypt the data and send it. Okay, this is your presentation layer. Presentation layer. Okay. Then what happens next? You have to now tell computer B, I have data to send you. So which layer is this? Your session layer. You now deal with the session layer. Now we'll assume computer B has given you the nod. Computer B has said, yes, I'm ready to receive data. Now you choose your transport layer. You now choose your delivery method. Are you going to use UDP, TCP, VoIP? It's a website. No, what will you be using? It's a website. It's ICMAN, TCP. You'll be using TCP. So now we deal with transport layer. Transport layer. Okay, right. Now the delivery method has been chosen. Now you choose the You choose the network, which is to do with which layer? Network layer. Now you deal with network layer. You choose the network now. Okay. What is the route that data is going to take? You now choose your network layer. After network layer, you must choose the exact device, right? So what do we deal with? We deal with MAC addresses, which is which layer now? Data link layer. You now deal with data link layer. And then finally, how do you send the data? It will be wired or wireless. You finally emit your data wired or wirelessly. How is that? Physical layer. Physical layer. So guys, can I draw an arrow like this and say? This will be when sending. When sending data. When sending data. And then from bottom to top will be when you're receiving your data. It will obviously be the other way around when you're receiving. Okay. So computer B will follow from bottom to top. Computer A will follow from top to bottom when receiving data. Okay. Are we all okay with this? So computer A, when it's sending data, the data goes from application layer to presentation layer to session layer to transport layer to network layer to data link layer to physical layer. And then computer B, when it's receiving, it starts from the bottom, from the physical layer, then device is identified, network is identified, then transport method is chosen, then what do you call, session is established, then it goes from bottom to top. Okay. This is a bit confusing, not a bit, this is confusing, okay? But we will be doing a lot of questions related to this, okay? Everybody okay with this? All right. Then guys, girls, can we have a look at the TCP IP model? The more practical model, the model that is older than the OSI model, the TCP IP model. Guys, last week we did a past paper questions where we did only the mind map, remember? Everybody, next week we have to do that question, okay? Last week we did a question about open source software and we drew the mind map, but we didn't answer the question. Okay, so next week for sure we will be doing that. Okay. Right, everybody, can you come over here? Can you guys come down to the OSI model? We'll have a look at that and call it a day thereafter. Everyone, OSI, not OSI, I meant TCP IP model. You all know what TCP stands for? TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. Can you guys read it? So TCP has 4 layers. OSI has 7 layers. Okay, layer number 1, application layer. This layer incorporates what? The OSI's application, presentation, and session. Is it clear? In the TCP IP model, application, presentation, and session are built into one layer known as application layer. Okay, right. Can you all read the next layer? The next layer is your transport layer. Transport layer is the transport layer. The TCP transport layer and OSI transport layer are the same thing. Responsible for choosing a proper delivery method, a suitable delivery method. Okay, right. Keeps reading it. Something important there. TCP uses only what? The name itself is TCP. So what delivery method does it use? Sorry? I'm asking what delivery method will the TCP IP model follow? Slow, not, what do we call it? So TCP, the name itself is TCP, right? So it has to use only TCP. Everyone okay with this? The TCP IP model uses only TCP for transport. Are we okay with this? Read the next one. Then we have the network layer. It's the same as the network layer. It deals with your IP addressing. Okay. Your network layer deals with your IP address. And then finally, you have your link layer or physical layer. It deals with what? your physical layer, and your data link layer. Are we okay with this? Can you guys read that? This layer incorporates the role of the data link layer and the physical layer from the OSI model. Are we all good? Okay, so guys, practically in today's world, which one are we using? TCP/IP. OSI is only a theoretical model to explain in detail how data transfers from one device to another. But practically in today's world, what framework is followed? The TCP/IP. Then guys, what about phone calls, internet calls? Can you come down over? Sorry, the last paragraph. Can you read it? The last paragraph. TCP/IP is the main protocol used by devices communicating on the internet. Each time device is sent from one device to another over the internet, the TCP/IP model is used to prepare and send the data. Okay, everybody, shall we quickly draw the TCP/IP model and draw arrows when sending and when receiving? Everybody, can you quickly draw the TCP/IP model? So what do we have? At the top, we have our application layer. Application layer. Then what do we have next? You have your transport layer. Then we deal with IP addressing, which is taken over by your network layer. And then finally your data link layer and your physical layer are combined into your physical layer. You can call it your link layer. So guys, your arrow from top to bottom will be when sending data, and this is when receiving data. When receiving data. Guys, girls, while you're writing, you all know your exam dates, right? Which month? Next month. Very good. Which week? Adil, you're looking confused. We're talking about the exams. 24th to 28th, right? Okay, November 24th to 28th. So guys, for sure, topic 1 I will question you all about. Topic 2, boys, look here. Topic 2 also I will question you all about. Topic 3 also I will question you all about. Topic 4 depends on how much we complete. So topic 1, 2, 3 for sure, it's going to be coming in your first term exam. Okay, then boys, what about your unit 2 paper? HTML, CSS for sure. JavaScript, a few questions. Okay, JavaScript, we're going to start very soon. We're going to be starting JavaScript. Okay, so JavaScript questions will not be a lot. It will be a few. Okay, so keep that in mind. Okay, last week of November it's happening. Okay, so please do keep that in mind. Guys, did I get this down, everybody? Okay, guys, we just have 2 minutes. We'll just have a look at VoIP and then we'll make a move. Okay, just have an introduction and then you can make a move. Okay, everybody, can you all just have a look at VoIP and then I'll wrap it up for today. Okay, right. Everybody, can you come down to VoIP and SIP? You all know what SIP stands for, right? Boys, SIP is Session Initiation Protocol. What is it responsible for? For starting a connection, establishing, very good. Establishing a connection, maintaining it, and then terminating it. Okay, establishing, maintaining it, and then terminating it. Okay, can you all read it now? Nothing much there. VoIP is a set of rules that is used to send data when one person is making a voice call to another person using the internet. When voice calls happen over the internet, we use VoIP. It was invented in 1995 and was developed to allow people to use devices other than their mobile phone to make a call. You can even use your laptop now to make a voice call. People use VoIP to make calls on devices such as their personal computer or laptop. VoIP is responsible, read it, for converting digital signals. Sorry, for converting, not digital, analog. Your voice is analog, no? For converting analog into digital data, compressing it for transmission, and then transmitting that data across the internet. Everybody okay with this? Read that sentence again. VoIP is responsible for converting your analog data of voice into a digital format, compressing it, and then transmitting it over the internet. VoIP uses a protocol SIP. SIP has the same responsibilities as the protocol in the application layer. Basically, what does SIP do? Shall I just put that note over there and wrap it up for today? SIP establishes a connection, maintains it, and maintains it and terminates it. Okay, this is the function of SIP. Guys, Adil, today you are not your phone, right? Today you are not fully attentive with me, no. Next time I'm keeping you alone. I think that's best, isn't it? By the way, I forgot what your name was, man. What was your name? Yetum, right? And all others I know. Okay, guys, all of you, your name you need to give me, okay? Okay, others, everybody else, take care then until we meet again tomorrow. Okay, take care, stay safe. See you all tomorrow. Okay, goodbye, everyone. Guys online, take care.